7? No? What?
What's 1 times 1?
It's 1.
Yeah, and then times it by 1 again?
Oh, it's 1.
It is 1, yeah. So all we're doing is we're multiplying by 1 7 times, but the answer is still 1. And Mustafa, what have you got for number 10?
171.
171. Absolutely excellent. Let me show you the answers there because you guys are excellent. You got all of those correct. Very, very well done. Now, the purpose of today's lesson and what we're looking at today is standard form. And I'm going to introduce what standard form is. Standard form is a way for us to represent some really, really large numbers and really, really small numbers. So it's really, really important that we can do that because as scientists, we may want to look at the distance to the sun if we're doing some calculations. Now that is the distance to the sun in meters. Now I'm a maths person and I like numbers, but even I think there are too many numbers in that number. That's ridiculous. Yeah, that's 149,597,870,700 meters. That is ridiculous as a number. But also, if we were looking at the width of an electron in meters, that would be given as 0.00000000000000001 meters. Both of those are ridiculous numbers. Yeah? So as mathematicians, because what I've told you before, mathematicians are lazy inherently. We want to make life easier for ourselves. So we're going to have a look at how we can write that in these terms. Yeah? So the reason it's important is because it enables us to use to display those really, really big numbers. And what we don't want is if you have a physicist who's looking at distances in space, what you don't want is for them to have to write out all those numbers. But likewise, what we don't want is to have scientists looking at atoms to have to use so many numbers as well. So here we can see, we can zoom in, and as we get smaller, we've got the grain of sand, and then we could go in there, and then we have cells, and then we've got a hydrogen atom. So that's absolutely tiny. Yeah, and apparently you get smaller. High energy neutrino and a strange quark. So we can zoom out from there. And now this is kind of standard. So we've got dodo, we've got sunflower, we've got a T-Rex, we've got a blue whale. Statue of Liberty. You can see we're zooming out, and as we zoom out, we can see we've got the Palm Jebel Ali, we've got Halley's Comet, we've got Mount Everest, so we've got Texas there. We're continuing to zoom out. We've got Texas, and then we have some planets. We've got Ganymede, we've got Europa, we've got Eris, we've got the Moon. Now this is where it starts to get interesting. So if I'm zooming out, I can see Earth there. You can see the Venus is bigger than Earth. We've got Sirius B, Now remember, Earth is there. Keep a picture in your mind of where Earth is. Sorry, Nora, you got your hand up.
Is this math? Because if
This
it
is math.
is, that's actually.
Yeah. Because what we're doing is we're zooming out, and I'm showing you how big some of those distances are, but how small some of those distances are as well.
Minecraft
And math
world?
makes it. Apparently, this is the size of a supposed
Yeah.
Minecraft
It's
world.
like 7 million meters.
Yeah, exactly. So that shows how big it is. And this is the thing, though. So what we're doing with maths is we're making it really easy to talk about those distances. Because if we didn't use that, it'd be really, really difficult. So because we said the distance from, the Earth to the Moon was however many billion of meters. So maths is making it really easy to do sums with those. Now remember where Earth is. If we continue to zoom out, we can have a look at how tiny Earth is and how far away it is. Keep an eye on where Earth is, the distance of Earth to the Sun. Now,